please take a minute to add your name to the attendees list. I dropped the note to stock in the chat. And we'll get started on that. I see some IBM folks here. Is Jeff from IBM here as well? Or is someone else going to be leading that discussion?
Ian will be the presenter.
Okay, great.
Yep, hello.
Okay, just let us know when to get started and we'll be ready to go. We'll have some slides to share as well. So.
Okay. Go ahead and get started in one minute, just so folks can join. If you're just joining, please make sure to add your name to the attendees list. Okay, great. So we'll start with just some quick points of order. Zach, are you here? Zach's not here, but I'll take this from Zach. So the EMEA friendly meetings have been rescheduled. They are at a new time that is more EMEA friendly, and they will also take place on Thursday. So this is, if you're East Coast or US time zones, this will be early Thursday morning. And Zach will be chairing those meetings, I think indefinitely going forward because they're outside my working hours. But he might appreciate some fellow chairs, some folks to help him with chairing. So those have been updated on the OpenSSF public calendar and also the shadow calendar invites that have RSVPs. And we'll also update links and stuff elsewhere when those happen. So that'll be the next meeting in 2 weeks on November 16th, which I feel like is actually the 17th. But yeah, it'll be Thursday and we'll be updated. Any questions about that? Yeah, that'll be the 17th. And then the December meeting will be on December 15th. Okay, cool. Real quick, I want to welcome new friends. So if you haven't been to this work group meeting before, can you unmute real quick, just say hi, introduce yourself and your affiliation.
Hello, I'm Zach Steinzler, not to be confused with Zach from Chainguard. I'm working at GitHub on the NPM linking packages to their source code and build instructions using Sigstore.
Awesome, thanks, Zach. Anybody else?
I'm Justin Kapos, a professor at NYU and created Tough and work a lot on Intodo and a bunch of other things in this space.
I am Jen Shavik. I'm with Boeing's open source program office.
Cool, welcome. I don't think we've had anyone from Boeing yet, so.
Cool, excited to be here.
Anybody else?
Yes, so I'm Ian Malloy. I'm from IBM Research.
J.R. Rao from IBM Research.
And this is Jiyoung Zhang from IBM Research.
David Edelson, IBM Research.
Ava Black from Microsoft and the OpenSSF TAC.
Hi, Ava, nice to see you here.
Thanks.
Anybody else? Cool. Hey, folks from IBM, I guess maybe you want to give us a little preview of what you're going to talk about, or a little more detail about your organization at IBM.
Sure. Maybe I can start with that, and then Ian and Jiong can tee up the presentation, and we can take you through that. We've been represented at the OpenSSF by two of our colleagues who are on this call. There's Jeff Borek and there's Matt Rutkowski. And of course, we know Jamie Thomas, who's one of our vice presidents, is leading is one of the leaders at the OpenSSF, working with Brian, who's also on the call. So we in IBM Research have been working on trying to address this issue of how to secure supply chain at scale, right? And especially look at open source repositories and come up with ways how to raise the bar, right? And so we've seen some of the example topics we worked on, like Sixto, for example. That's one of the projects in the OpenSSF, which is more based around the reputation of developers and credentials and so on. We've been working on a different angle on this, which we actually call code genome. And it's really based on the idea of, because it's possible if you raise the bar on security to spoof things like developer credentials, and there are other threats and other attacks become possible. Is there a way that you can go to the code level, and what is it that you're able to do at the code level? And so, for the better part of this year, we've been actually working on some of these ideas and sketching them out. Ian and Jiong will take us through this. Maybe you can start presenting, guys. And so our request to you is, to get, you guys are spending a fair bit of time across the industry in this space. Would love to get some feedback from you on some of these ideas and how we are, pursuing this, and how we might be able to make it much more usable, consumable, and practical as we go forward. So I'll pause here. Let me also ask Jeff, do you want to weigh anything in, please, before we turn this over to Ian and Jiong to present? Jeff Borek.
Thanks, JR. And yeah, we're excited to preview this technology with the Securing Repositories Working Group. And we're interested in finding ways to effectively share some of this to help remediate some of the challenges that span the open source ecosystem. And so we're here to preview and sort of, again, be flexible on the approach on this and be, radically transparent and see where we go from here.
Okay.
I would just add briefly that I would add just briefly that as the governing board chair, Jamie Thomas has been very supportive of the good work that IBM has been doing in this space, and is excited about the possibilities of this technology. Ian, over to you.
Right. Thanks. So everyone can see my screen. I had to do a quick shuffle there, actually, while JR was speaking. Okay, great. Yeah, so again, I'm Ian Malloy. I'm the department head of the Security Research Group in Yorktown, and I want to bring forward some of the work that we've been doing. Ideas have been kicked around for a number of years. I think some of the recent events that happened, probably the last, let's just say 6 to 12 months, really kind of spurred this on to develop it a whole lot more. And you'll understand that as we kind of go through. But in the interest of time, let's just get started. So we probably don't have to go through any of this. This is kind of one of our slides when we bring people up to speed who aren't familiar with it, but supply chain attacks are pretty prevalent these days. We actually see quite a few of them at all different levels of the supply chain, from attacks against developers, developer credentials, repositories, and then kind of going after IT systems. So won't go into a lot of detail there. But when we look at the whole supply chain and how it's actually built out, there is this pipeline, this process. When you go from the developers who are going to add code, they're going to build it, compile it, and then eventually distribute it. And there are a whole bunch of tools that have kind of built up to help secure that. Whether or not that's looking at vulnerabilities, all the great things that kind of integrate directly with tools like GitHub, that let you find them as early as possible. Integrity of the CI/CD pipelines, reproducible builds, all the great work that's been going on with Entoto and Salsa. And then eventually getting the SBOMs, the bill of materials they can actually provide to the end users. And have that provide some form of an assurance of what's going on. And what we're actually going to be presenting and proposing here is something that's a little complementary to these technologies. So it's not one of these things that it makes it so you wouldn't need these, but again, it might address some additional security gaps that we actually see. So Jay already kind of mentioned a little bit, but what we actually want to propose is something like a software fingerprint to help raise assurance of the software, the code, the binaries that we actually see. And when we think about this, we start off and you've got a hash. It is something that we can use to verify file matches precisely. If there's a single bit difference, then there are large differences with the hash. Signatures allow us to then kind of assign some form of trust to that, assuming you trust who signed it. Then effectively they're testing that, yes, this is what they have, and it's a blessed copy. It hasn't been modified in any way, and who it claims to have come from. But this actually requires you to have full trust in the signer. And as we kind of saw in the previous chart, sometimes developers do actually get compromised. Salsa tries to address this with two-person verification of all software packages or all commits, but sometimes it might not be something that any different package maintainer can actually have. It's very, very costly, and some different vulnerabilities or breaches to actually still make it through. Fuzzy hashes, something like SSDeep, is kind of another technique that is kind of similar, which would actually provide a partial match for a file or for known files. And what this can tend to do is find some small differences between files, but it really lacks the semantic understanding of the files, their purpose, and what they're actually trying to do. And just to kind of show a quick example, I was playing around with actually running SSDeep on different implementations or different builds, different distributions of SSDeep. So RHEL version of 2.14, two different Ubuntu versions of 2.14, and compiled it with Brew on my laptop, and they all come up with wildly different fuzzy hashes. So none of them actually match. So it's really difficult to actually verify that they're all different implementations of effectively the same binary, the same code. So what we kind of want is this feature where you have stability across versions and continuity. And also robustness for legacy. So you can go out and scan all of your systems and verify that this is the same code that's been running where you might not have the hashes anymore. We can also kind of think back to, I guess, the old Ken Thompson papers, Reflections on Trusting Trust, where you might not know where you've been compromised. Was the developer that was compromised? Is there something the compiler is actually doing? We've actually done some tests recently where we thought we had potentially disabled certain features, but they still actually make it through to the end binary. And so what we really kind of want is a way to verify from the source code to the binary, the full integrity of everything, and do that across deployments, and address some of the recent things that we've seen where you might have a version number that actually doesn't match because potentially someone added additional patch, or they backported some security patch or additional functionality because they had to do that for your specific system. So when we kind of go back to the supply chain view, while there are all these tools that really are doing a great job at locking it down, there are still small places where there are potential gaps, potential weaknesses that attackers can actually leverage. Again, anything from the sort of point of entry, compromising developers, and then at the end, you can kind of think of this, well, we have a huge legacy problem. So until we're all on a Salsa level 4 build system, there's going to be tons of code out there, tons of legacy deployments. Not everyone has great CMDBs or knows exactly what's being deployed. And so the ability to be able to go back and verify and fingerprint all of it is eminently useful. So what I want to do is actually hand it over to Jiang, who will actually walk you through a little bit of the fingerprinting technology we have and how it works.
All right, thank you, Ian. So we call our project as a code genome because fundamentally what we're trying to achieve is to find the meaningful fingerprint that represent the functionality of the code. And this is the kind of beyond synthetic matching. So we want to understand or trying to find the functionality of the code. That's why we call the this is kind of the semantic match or the semantic search based on the code functionality. And here we show the 4 different blocks of the black screen. And this is a kind of the small example to demonstrate what we are trying to do. On the left to right, these are the same kind of the computation. As you can see, we injected some kind of assembly code inline, or sometimes we put kind of the changing the control flow, kind of doing some kind of the obfuscation or kind of the modification about the control flow. And then of course, when you compile and they will result in different binary, of course, even the size is different, as you can see from the object on screen and behind. And what here we're doing is we generating the code genome based on each of the binary code, which is the bottom center. You see the black screen and looks like some kind of IR format, and that generates some kind of the graph, some kind of the graphic representation. And this is actually the code genome we generate from the 4 different binary, and then that all boil down to the same representation, so that we can search through the different architectures or compilers or different optimization level. Of course, this is quite challenging problem, as you may already know. So we cannot claim 100% coverage, but we are getting there. And we are trying to improve our technology and to handle many different corner cases. But we are getting there, and we are improving our code genome functionality and the quality, and that's something we are getting there. So this is a high-level overview, and Ian, maybe move on to the next chart. And how we generate the code genome in terms of kind of pipelining or kind of the step. On the bottom left, you see there is a source code, and which is noted as optional because we mainly starting from the binary. Of course, if we have the source code, you can compile to get the binary, or eventually what we care is the IR representation, intermediate representation, because this is something, as you may already know, so this is some architecture or the platform independent representation of the code. That's why we're focusing here. So from the machine code, we first leap into the raw IR, and from there we do lots of transformation of the IR to make it more kind of consistent across different kind of the binary. And we do the lots of canonicalization, and then do the lots of the cleaning, and then we eventually get some kind of canonicalized form of the IR representation of the code block. And then we convert into the big code, and then we do the lots of different style of the embedding. And this is one of the example. And using one of our team members, he's the previous research work called the Sigma, so which is about the representing the speed representation into the images, so that we can do the comparison between different images, so that we can measure the similarity. So this is how we generating the code genome based on starting from the actual machine code or the source code, and then eventually we get to some kind of representation of the code genome, and then which we can do the comparison between the code. And the main benefit is we don't necessarily rely on the source code. And of course, if we have source code, it is great. And then we can do some kind of ground truth matching it. But in case you don't have the source code, and over the time, maybe some of the legacy code, you may lost access source code, or even the commercial or proprietary code. Of course, you don't necessarily have the source code. And even those cases, we still want to do the verification. So that's why we're focusing on the binary analysis. And also, as Ian mentioned, so there might be a compromisation of the compiler, like Xcode Ghost is one of the example. And that's why we don't necessarily want to trust all the building process, but we eventually verify the binary code, which is the code that actually running on the system in the end. Because source code, binary code, it doesn't necessarily guarantee they're going to do the same thing. So that's why we want to inspect or verify the binary code that is actually running on the system. Yeah, maybe the next chart. Okay, so using this technology, the team have been exploring many different use cases, and we picked maybe the 2 most relevant use cases for the team. And the first use case was, as you know, of course, last year at the end of the kind of the year, which is at the perfect time of the holiday, and big hit about the Localz. And then, as I mentioned, the software genome is about the finding the core functionality or the core representation of the code. So we took that idea and finding where the vulnerability in the Log4j, and from the vulnerable version of the Log4j, and then using that to searching through our system and the infrastructure and the organization to finding where this Log4j is still deployed and used. And this also brings the quite interesting kind of challenges. So like software is not necessary you have this a single binary. There's always package and package of the package, and of course package of the package like zip, tarza, you imagine. So there are lots of dependencies and also a lot of the layer of the software. We have to peeling the onion to get to the actual code, and then dependencies get quite complicated. So there is lots of kind of the beyond the software genome, we trying to come up with a robust technology or the framework to analyzing to get to the nugget of the actual code. So that's how we scan our organization, and we are reporting a lot of the kind of the matchings in the deployed in the system. And we actually, and here we present the Log4j. Of course, the same technology can be used other type of the vulnerability. So team is currently kind of pulling the latest version or the new vulnerability whenever it's coming out. We're pulling it, and then we kind of generating quote unquote kind of the signature or maybe the genome representation to searching through and finding the vulnerability. So this is one of the kind of the use case of the using the genome technology for the security purpose. And maybe the next chart. So this might be more interesting for the audience maybe today. So another use case we're focusing on the genome technology is the SBOM verification. And as Ian mentioned, SBOM is a great kind of the technology or the standard to provide what is actually the ingredient in the software whenever it's deployed or delivered. The issue here is that the user or end user, they just need to trust what is written on the SBOM, but there is no guarantee that SBOM is correct or the complete. So meaning that there could be some mistake by the human or some developer, maybe they didn't properly understand SBOM format, so they might miss something. Or sometimes some of the vendors, we know there is many instances like some of the vendors is kind of infringe the open source like a GPL license. But of course, for that case, they don't want to include or claim that as part of the SBOM because they don't want to get into the kind of legal kind of dispute. So that's why there's always chance it might be incomplete or incorrect. So that's why we want to verify whether SBOM is really matches with inside the source code or inside the software. That's why using our technology to understand what is the inside of software, meaning we are doing the software composition analysis using the genome technology. So given the software, we verify or generating what is inside, and then we generating the SBOM or the verified SBOM to guarantee, okay, this is a correct SBOM, this is what they claim, this is matched, maybe this is not matched. So this is the kind of the capability we are currently actively building it at the moment. So in the next chart. So the reason I mentioned the trust and verify is that we saw there are many different tools and many great tools, especially from Cyclone DX community, and then there is whole effort from many different companies. And there is very kind of great tool set to generate an SBOM, but we noticed that most of the tool is focusing on the generating SBOM from the metadata, like pip file or maybe some requirement.txt or the package manager. So these are great source of information to generate SBOM. But the issue is that maybe it might not be complete. So for example, on the right top corner, there is a recent article about kind of the official, the Docker Hub, some of the images, they have the incorrect version of OpenSSL is claimed. So this kind of the mistake may happen over the time because SBOM is still new standard and it maybe takes time to people to properly adapt this technology. And then we also internally tested some of the kind of SBOM generation tool, and you see the mid left-hand side, the Docker file. As you see, simple Docker from the Ubuntu image, you update, and then you install the wget. And then of course, from the SBOM, you expect there is a wget as part of your SBOM kind of the generation, which is true. But on the right-hand side, you see there is a line number 6, which is effectively basically taking out the package manager, the metadata information will be removed. When that happened, actually the SBOM, the generated SBOM doesn't contain the wget inside.
So Jiang, in the interest of time, let's just start jumping to the asks. So I'll show just a couple other things. So we had a demo planned where we're going to show that we could identify, download, recompile something like wget, an unknown package, and have our tool automatically be able to identify and recognize it. But we'll skip that for now. We are currently building a bit of a service where we actually have a UI that we hope to actually be able to make live, where people will be able to go and actually see how it works. So what we have currently is several different techniques that would actually compute these different genes, support for both multiple formats for binaries, packages, and even different types of bytecode interpreted code. Very large cloud native application for processing this. We're trying to process as much software as we can to make sure that the genes are robust and we can correctly identify all the different software packages, and are trying to currently perform a large scale evaluation. What are we actually planning on releasing? Well, we're hoping that some of the initial versions of the gene creation techniques that we have are things that we can actually open source, plus the service that I just kind of showed the screenshots that would actually demonstrate the technology. Sorry about that. And utilities for actually being able to handle and query the large database that we're actually building up and everything. We welcome any kind of thoughts and feedback, support, insights, and different use cases.
That's totally cool, and it shows what happens when you leave the bowl of Halloween candy out. So
yes, no.
Keep going.
All right.
It looks like there's an appetite for a demo if there's time, and I know that.
I don't think there's going to be time for a demo, Matt, but I do know that there's a number of questions out there.
Okay. Yeah.
And we can come back. I think we can come back for a demo or set up a special one. But I'll defer to the chair of the working group as to our time allotted.
Yeah, I'd like to take questions and then maybe run through the rest of the agenda quickly and see if we have more time at the end for a demo.
Okay.
Yeah, does anyone have questions? Zach, I see a hand. Please use hands.
Yes, first of all, very, very cool technology. I'm wondering how you're proposing to generate all of the hashes associated with the vast number of software libraries that are in use in the world.
We're probably going to start a little small, looking at all the major packages that we see in major distributions. That's probably where we're going to start building this up. And if people have packages they think that these are the ones we definitely need to ingest, willing to take that as kind of thoughts and feedback. So we are thinking of different mechanisms where we'll be, are syncing different repositories, having different projects that we'd actually start pulling in, and kind of using that as a base and then building it out as we go. Making sure that the genes that we compute are, meaningful first before as we kind of go and scale up.
We'll take any suggestions from this working group, because that's
Yeah.
what the charter of this is. So
There is a very challenging question or the practical question, but over the time, the team has a vision to provide some kind of open service, like kind of search engine for the code. So you put maybe the hash. Of course, these days you can search by hash using the virus sorter, but we want to go beyond. This could be some kind of quote unquote the genome representation we have, or maybe some of the metadata you have with code. So we want to provide all various different kinds of analytics and outcome to kind of as a kind of one place. So that's where we have the vision.
I think Ava was next.
Thank you all for the presentation. I think this is really exciting approach. I'm curious if you've considered how the genomic fingerprint of software relates to dependency resolution of software. Is it, for example, somehow inferable from a gene sequence, if you will, what the content or the dependencies were, or some way to connect them or map them? Since you've probably seen my work on GitBomb really focused on dependency resolution. This looks not the same, but I'm curious if there is overlap.
So sure. I've got one thought there, and not sure, Jiang, if you've got anything you want to add.
So I think that's a really great question. And here, so in the backend, so exactly to tackle or kind of address or to provide those capability to infer the dependencies, we are not storing as kind of the kind of relationship database. Instead, we are actually building the knowledge graph, the behind the scene. So that where we represent the dependency or the kind of relationship between the binaries or binary to the package, the package to the Docker container. So we want to keep those relationship between the binary. And then from there, of course, we can do many interesting things like provenance from the code and how the code got evolved, and maybe when a vulnerability coming out, whether this vulnerability also used for other packages, other projects, so all kinds of many different interesting kind of the reasoning we can do on top of it. But that is really kind of the great question.
What the one thing I wanted to kind of chime in there that was kind of interesting would be, I guess, two things. One would be, we use Log4j as an example. It was, the gift that kept on giving. And one of the reasons for that is when you look at a jar, very, very infrequently do you actually have like log4j.jar that we actually found. Because lots of people would actually build with Maven and it would package all the dependencies inside there. And so it actually became very, very difficult. I mean, I think Jiang mentioned, but we scanned hundreds, if not thousands of systems within research with, a very, very early version of our tool, and actually found hundreds of running instances of Log4j that had, all the other scanners that they had actually tried had missed. Partially because we weren't, I like to use the word turducken, but, unpackaging, unrolling and unwrapping all the different layers of the software dependencies until you actually find that, hey, within this jar is the following class files, and those following class files actually match the gene sequence. And I'm really kind of curious on applying this eventually to things like Go applications that tend to be statically compiled, and be able to look at that and say, hey, we've got little bits of code from here, little bits of code from there. They've all been added together into this larger package. So it's kind of the dependencies, but looking at it, these different layers, or people that just like, I copy this code and pasted it in here.
Fascinating. So that the sort of gene sequence resolution is that fine grained. That's really cool. Thanks for sharing that.
Yeah, I'm not sure if we actually mentioned this. We actually hope to have genes computed at multiple different levels of granularity. The preliminary version is going to be at the file level. We had things at function level, and we're also, again, evaluating what the right level of granularity is.
Well, that goes right into my question, which I think I was next in the queue, which is about granularity. Like you showed very small snippets in the slides. I think that makes sense, but I guess, what level of granularity are you looking at, and how do you account for like the presence of something in a file? Like, let's say a malicious snippet or a vulnerable snippet is included in one file, but then it's also in a completely different position in another file. Like, does this account for that?
Well, the hope is that if we do it at the functional level, we would have like large sequences, like large collections of genes that we actually see within a given file. And if you kind of reorder the positioning, the hope is that, yes, it'd be invariant to like the gene would actually still be there. The hope is that it is robust to different forms of obfuscation, as kind of Jiang showed. So we definitely have that kind of in our minds as we kind of go through into the evaluation.
Yeah, so granularity is one thing the team spent a lot of time to discuss. And of course, file level could be too coarse. And if we go to the basic block, or maybe even at the gadget level, it's going to be too fine grained. So maybe there are too many genes we need to create, and maybe some of the gene may not be that meaningful, because that's the reason we want to start from maybe function level would be the right level, because the function, by definition, function should be kind of the one of the unit that provide the meaningful computation. That's why we decide function will be the good granularity to target, but we definitely keep track function to file, file to package, or file package to container. Those kind of relationship we are still capturing in the knowledge graph.
Thanks. I think Meta was next.
Yeah, I was wondering if you could talk a little bit about sort of that obfuscation and other sort of how you're handling this, and actually more generally, sort of what is the threat model there, right? You've mentioned a couple of times sort of trying to sort of keep some of the malicious suppliers honest if they're lying about stuff on the SBOM and all of that sort of stuff. How confident are you in that sort of being able to handle effectively a malicious supply, which is that part of that sort of your threat model and how it's going to work?
Yeah, that is, of course, a part of the threat model, but we need, I guess there is a reason we say, well, we start with a preview of our technology. So we are developing or evolving our technology to address many different corner cases, but we are pretty sure in this space, as you experience, there will be a lot of corner case, very creative way to bypass all different kinds of kind of de-obfuscation technology. So we're trying to incorporate many different things and many different optimization at the IR level as much as possible. So we are trying to develop more and more technology to address many different kind of corner cases. And this is actually one of the reasons we want to interact with the community, because there's lots of development in the binary analysis, I know from the research community and of course industry community. So we want to adapt and incorporate into the play so that we can leveraging or to get the benefit from this development in the community, and of course want to give back as kind of the service. So of course this is a challenging problem, but we are working on it.
Maybe two more proof points. Some of the guys in Jung's team have, have done some work in malware analysis. That's actually how some of the ideas originally started. And they're looking at, two different disassemblers might actually come to wildly different conclusions based off of, non-word aligned instructions. And some interesting little things like that malware tends to do. The presence of hackers is another thing that we have in our mind. But we're starting with, the open source software, the low hanging fruit, making sure it works there. But we're definitely aware of some of the, different things adversaries can do. The other thing I'll mention is that we do have a large team working on things like adversarial machine learning, which would actively be attacking any of these types of techniques. So we're considering some of the different findings for that, that could potentially help address the issues and let us do that evaluation. So very much to the forefront. Time will tell as we kind of do more evaluations and see how well everything works.
Any other questions? So I'll add, one thing that seems particularly useful for and might require a much smaller data set is malware detection. So I'm assuming you probably already thought about that. Is that maybe like a first step here that would be useful to provide a service that, we have a data set of known malware, fingerprints for all that, and then we can sort of provide a service that can scan some arbitrary piece of code or software and see if any known malware is present?
So that will be really super useful security technology or the use case. But at the moment, as you present in the use case 2, we're currently focusing on the SBOM, more focusing on the open source. The reason is, since we are still developing technology and we want to have the good mechanism to evaluate whether our finding or the result is the meaningful enough. So for that, that's why we're focusing on the open source side, where we have the ground truth from the source code and whether our finding is really makes sense or not. So we first want to do the verification across many different data sources from the open source. And then we want to kind of look into the more commercial and even the malware side, where of course we don't necessarily have the ground truth, but we want to kind of test out. But first, our main focus would be the open source, and that's where our focus is at the moment.
I think Better, you've got an old hand up, so Jeffrey.
Thanks, Dustin. And yeah, I just think we are probably ready to yield time now, but I wanted to conclude by basically doing a quick show of hands. If the folks attending the call want to either provide a thumbs up or raise their hand as an indication that this looks like interesting technology that the working group would like to follow up on, we can talk about coming back and doing a demo. We also want to continue to socialize this with perhaps another working group at the OpenSSF because we think it has broad applications. But if the working group here is interested in this, Dustin, whatever the most appropriate way to capture some feedback would be appreciated. We'd like to continue to preview this and may even discuss it publicly next week at the member summit, and but would like to come back and line up a demonstration as appropriate.
Yeah, so this is a work group that's focused on the software repositories themselves, which is why I was sort of asking a little bit about malware, because that's something we've discussed in the past.
Yep.
And so, yeah, I think there's maybe some ideas about how a software repository could use a service like this. like malware is the first thing that comes to mind for me. But I think we also have a working group around identifying security threats with OpenSSF, and they might be interested to see this. And yeah, I think if there's another one that might be a good fit as well, I might like to hear about this. But
yeah, supply chain integrity is another one that comes to mind.
Package analysis is another one that would be potentially interesting because they are effectively trying to find bad packages out there, and this feels like it will be very useful there as a way to group bad things.
So yeah, I'll say thanks for coming and chatting with us. This seems super interesting. I'd say definitely come back when there's a service that we could play with. I think we'd be very interested to see that and try to experiment with that a little bit. Okay, I'm gonna switch over.
We'll also try and come back at a time that's maybe more EMEA friendly as well, so we capture that side of the group as well.
Yeah, you're welcome to do that. We do record these also, so ideally folks can watch the presentation, but it's hard to do Q&A over a recording. Okay, so moving on the agenda real quick. Let me just take over the screen.
Dustin, I think you're muted.
Does this thing when I present my screen. It's really annoying. I actually want to present my window anyways. Let's do that. Okay, you can hear me now. Yeah, so we have Justin here on the call, and Justin's been working with folks in the Python ecosystem for a while on a proposal that's been around for a while to integrate TUF into the Python package index to do repository signed metadata and artifacts. This has been in progress for a very long time, but we're at the point now where one of the things that sort of came out of this work was the creation of a design doc that very specifically describes like how an existing repository would add support for TUF. I wanted to share that with this group here for folks that have other language ecosystems that might be thinking about integrating with TUF, because I think this would be a really helpful resource. But also Justin's here to answer maybe any questions about what that might look like. And yeah, that's all I really want to share is that this is still in progress for Python, and this design doc might be a good resource. Any questions?
You can't see your screen, but I'm assuming you're sharing something.
I saw it was just me.
Yeah, I was just, let's see, is it now? Yeah, I think so. I wasn't sharing anything, but it's this line item in the notes. And it's quite a long document, but it's about how API will integrate with TUF. Any questions?
Can you hear me?
Yes.
Hi, this is Sumana. I'm one of the people at NYU who's worked with Justin a little bit on this. And I just wanted to mention that there's a number of people who worked on this. You'll see their names in the comments, especially on the document. And I just want to give a shout out and at NYU and elsewhere who have helped contribute to this to make it more likely that we'll be able to work out all the design details so that we can integrate TUF in here.
I saw a question for Justin from Trishank in the chat about how TUF relates to PyPI 6 in Toto.
Okay, yeah, I'm happy to take that. So we've been talking with the SigStore folks about, and I think the likely path forward for SigStore is going to be that the key type in SigStore, which is done by Fulcio, will become a key type inside of TUF. And so effectively, people that want to integrate SigStore will integrate TUF and then use that key type rather than like just doing SigStore and not getting the namespacing stuff like this from the TUF side. So right now we're in the process of working through some of those details. as for how in total relates to this, there was a very excellent blog post put out by someone at Datadog. Let me think. Oh yeah, it was Trishank, who described a lot of the integration work and things like that, and really did some fantastic work in that area. So you know, we would probably follow that model of integration, because that's one of the common pathways that we've had for tough in toto integration in the future, or in the past, and will probably be that way in the future, given some of the ITE and like proof related work for doing it in Optane and other places.
Any other questions? Okay, I'm going to hand it over to Betty, who's going to give us an update on the shared repository help desk proposal that Jacques was working on.
I'll share my screen. I don't have a pretty presentation, but I talk better when I have some points. So hope you bear with me with my Google Doc presentation. Okay, well, hello, I'm Betty from Shopify. As Dustin mentioned, I'm just giving an update on how the proposal presentation went with the TAC meeting from yesterday. Also, as Dustin mentioned as well, this the shared repository help desk proposal is largely championed by Jacques. So I am a less charismatic person that you're stuck with for the moment. But I also don't have as much context on this as well, so I can't speak to it as well as Jacques can. That said, here we go. So some background context on what the proposal is for anyone who's not aware. So we have a shared help desk proposal that was shared and surfaced out, and the key goal of it was to propose a solution to help software repos manage MFA reset requests, since that is high risk and time consuming. And the goal is for software repos in general to like roll out MFA requirements to larger and larger cohorts. And in order to support that, we proposed creating a shared help desk to alleviate some of the MFA reset requests portion, the support that comes with it. And so as a recap from the last meeting for the Secure Software Repos Working Group, Jacques had asked the working group if they were in favor to support bringing this proposal to the TAC. There were no oppositions, everyone supported it. And so the next piece was actually bringing it to the TAC. Jacques is away for another 4 weeks, I believe. He's over in Australia getting married, so congrats to him. So in the meantime, he had asked the working group if anyone was available to take it to the TAC. No one was, and so I, as one of his team members, as well as other team members, kind of held that torch for him in his absence. So Ashley Pierce was the one who presented to the TAC, and the goal was to bring it to the TAC and ask to bring it to a vote on whether they support that proposal. But ominous, dun, 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 we postponed the request to the vote. And that's mainly because the TAC and other members who were in attendance in that meeting had a number of questions. The key thing that was highlighted that became like, I guess, evident to us is that the proposal in its current state lacks a lot of details around the hows and like more specificity. It's currently too ambiguous for the TAC to vote on. And I think that's like fair feedback, and they had really great questions that they've asked. So instead of like voting on something they're unclear about, the goal was to take it back and we need to do some rework. That said, there is some like good news to share, which is that the sentiments and the theme that I think we took away from that meeting was that, members of the TAC said they support this idea conceptually, and they agree that the problem is worth solving. So what I heard was like, no one was saying no. What they're looking for is just more details on what this proposal actually looks like, and not only just having a shared help desk as the solution, but also coming up with alternatives as well. So that brings us to the next steps. We need a way to like consolidate or gather more feedback and the actual, I guess, a consolidated list of questions so we can address them. So to do that, we had asked Dustin if it makes sense for us to open an issue in this working group's repo. He seemed to have given it the thumbs up, so that's what I'll be planning to do, probably later today. If not tomorrow, I'll create an issue in our working group's repo, which is this repo right here. I'll share the link in the doc once I'm done presenting. And in there, we'll have an issue where we can like have the discussion, get more suggestions, get feedback. And the goal is to create a concrete list of questions that we can then focus on addressing. I also want to call out, I know we're short on time, but in the conversations with the TAC and other members in that meeting, they had mentioned that like today could have been a good opportunity for them to join us to have some discussions here. I know we're short on time, so it might not be viable at this moment. So given that, I think the area that I'm going to focus everyone to start giving that feedback on would be to the issue that we're going to create in the working groups repo. I do have an ask. This is, as I mentioned, largely Jacques' initiative that he's worked with this working group, and he's gotten feedback from other ones as well. But I was wondering if anyone is available over the next few weeks while Jacques is away to like continue making progress on it. If not, like I think the best path forward is to one, collect more feedback in that issue and gather those questions, and then two, we can wait for Jacques' return to then like work on that proposal some more. The one thing I want to highlight or call out is that the governing board meets to like plan out 2023 budget in early December. I think Jacques comes back around late November, so I don't know if that will be sufficient time to get it in for the budget planning, but from what I understand, even if this isn't presented before then with like a more fleshed out proposal, that it is possible even like early next year to continue this conversation. So the door to get funded is not like immediately closed if we don't make it for December. Yeah, that's all I've got to share.
Cool, thanks, Betty. Real quick, can I ask you to just drop a link to this document in the notes doc? Thanks. And yeah, is anyone, so I said that we could create an issue in the repo. I think that'd be a good way to have an async discussion about the tax questions about this proposal. But yeah, if someone wants to lead that in the interim until Jacques returns, feel free to take ownership of the issue in that repository when it's created. And Betty, I'll ask you to just drop a link to that issue in the Slack channel and the notes and that kind of thing when you create it.
Cool. Okay.
Awesome. Any questions?
I'm happy to answer any questions if you all had some for the TAC left over from the TAC meeting.
Questions about questions?
I don't think I have any follow-up questions yet, Ava, but if we do, we'll definitely funnel them your way.
And if I'm not in that Slack channel, feel free to tag me if you have any questions, just to get my attention to it.
Sounds good. Thank you.
Thanks. Okay, 5 minutes left. Last thing on the list, Zach Newman is not here, but had thrown in an idea to talk about our stuff in a future meeting. For the tough folks that are on the call, maybe you could tell us what this is. We can decide if we want to hear more about it.
Yeah, so this is a repository simulator for TUF. The idea is for it to replace the it basically to be used as kind of a sandbox for repositories, the repository side of TUF, to experiment with the way repository setup could go for PyPI and others, a sandbox for that work. I think that I haven't worked on it myself. I think a lot of the folks at VMware have done a lot of the work there. and they're all, I think, in Europe, and so probably aren't here today. So maybe we should do it at some, at the EMEA meeting sometime, one of them be able to come and talk more about that in detail.
That sounds great. I'm gonna just tell Zach, we said, let's do it and schedule during the EMEA friendly meetings. Cool, okay, so yeah, in interest, I'm guessing the IBM demo doesn't fit into 4 minutes. So is that an accurate assumption?
I don't know, Jiang, do you want to show us? It's basically, I think, showing a Swagger interface in 4 minutes, unless we also build the binary from source. What do you think, Jiang?
I can do quick demo. I'm looking for where is my screen? Here. Okay. I try to be quick. Okay.
Yeah, we're showing the guts instead of the UI, I think, for this.
Yeah. So there is a reason why I call preview. We don't have fancy UI yet, so we are currently building on it on top of it. But this is more like behind the scene, how we develop the kind of the query and service. So this first UI, what I'm going to do is, so one day, so while we're developing our technology, Ian gave me some random Debian packages, and he just gave me these random Debian packages, and he just asked me, can you tell me anything about this Debian package? So, okay, so we are currently building, and let's try to figure this out, what this package is. So we submit to the system, and what it does is behind the scene, it is analyzing this binary and trying to collect all the information. And this is job ID. I just submit it. And this will show the progress. For example, job, of course, is started. That is great. And for the Debian packages, as you may kind of work on the rest of the Debian packages, this is actually the AR kind of file. And inside, of course, there are many dependencies inside. Like these are the two children, bunch of the analytics. I'm going to skipping for now. And if I just refresh, it will do the unpacking. One of the inside file is Debian binary, and there is the data.tar.xg, which also has another children, which is spit out of the tar file. Okay, it's still unpacking it. And let's see, is it unpacking? Or still doing it? Looks like it's still doing it. Okay. Where is it? This is. Okay, this file is existing somehow. It is okay. That's weird. I already cleaned up, but somehow this one decided to doing it. But all right. So for the sake of time, I'll just skip for now. So inside this is actual top file, and I guess one of the logic is if it's already processed to reduce the performance time, so we just skip it.
Yeah,
and
I'm looking at that right now.
Yeah. So
So
inside
it's
actually
because it already existed.
Yeah. So sorry about that. I already cleaned up, but somehow, yeah, this guy decided to do that. So after that, what happened is that one of the file is actually this binary, which is actually the Elf file inside it. And then we query to our knowledge graph. What do we know anything about this binary? And this is the query and the result. For example, this query, this is one of the file we just submitted from unknown.debian packages. And inside there is a file called unknown. And then the first hit of the result is actually the matched with the wget 1.19.4, which has a matched count of 118. So these are the list of the function that matched with the specific binary we just get from we just submit to the system. And then there is more detail about what file type is it, what is size, and what is the value. And then this will show the what is the closest match. That was the top one. And then the second one is actually coming from the official Debian package from the Ubuntu. And this is the package name 1.19.4 and this. And then this is inside there is a wget from this Debian package that also has 118 kind of matched the signature or the genome of this binary. And then from here, I confirm, looks like, hey, Ian, looks like this is wget. And I think my best guess would be this is the version. And the Ian actually confirmed this is the kind of source code he downloaded, compiled, and gave it to me. So this was kind of the one of the wait till we can do the composition analysis about the packages and the binary. So I guess I had exactly 4 minutes for the demo.
Yeah, that's perfect. No, that's great. Yeah, I would say also, like, if you want to put together a little screen recording or video or something, we could share that in Slack. I think folks would be interested to see that as well. But yeah, that's great. All right, awesome. All right, we're out of time. Thanks everyone for joining, and see you in 2 weeks, the EMEA friendly meeting. Take care.
All right.
Thank you. Bye.
Bye.
Bye.